This section will cover financial exponential growth and decay models. Let's begin with simple interest. Simple interest is the amount of interest for an investment or loan, P, and that stands for the principal, which is the amount of the beginning of the investment or loan, with the simple interest rate account R for a period of T years. So this interest rate R, you have to make sure that you write R as a decimal. And that holds true for all of these formulas in here. So for some reason if you're given 5% as the interest rate, when we plug that into the formula, you would put in 0.05. So the formula for simple interest is I, so interest, equals the principal, so the amount of the loan or investment, times the rate, times the time, which again is the number of years. Let's look at an example. Suppose you invest $20,000 into an account earning 5% simple interest. What will the value of the investment be after 6 years? How much interest will you have earned after 6 years? So we can use this formula to calculate the amount of interest and then add that to the principal value to see what the amount of in the account is. So let's figure out how much interest they've earned after 6 years. So interest equals the principal, so again that's the amount that you either invest or take a loan out for, times the rate, so we had 5%, so we would write that as a decimal, 0.05. Remember, to go from a percent to a decimal, you take the decimal point and move it over 2 spots to the left. So the principal times the rate times the time in years, it said for 6 years. When you substitute that into your calculator, you'll get $6,000. So that means that after 6 years, this investment earned $6,000 in interest. So the total amount in the investment after 6 years is going to be what they started with, the $20,000, plus the amount they earned in interest, which puts us at $26,000. So this means that after 6 years, their account is now worth $26,000. So simple interest is great, but in the real world, usually compound interest is what's used. So the difference between simple and compound interest. Simple interest is just interest that's accrued based on exactly what the amount in the account started with, so the principal value. So if you start with $20,000, the interest is only made on that $20,000. However, when you deal with compound interest, it doesn't just put interest earned on the amount that you start with, but it's the amount total in the account. So every year you're earning some interest. So when you do compound interest, the next year you're going to earn interest on not just what you started with, but also the amount that you earned that first year. Now the second year you're going to get interest on all of that total amount. So the amount that you make with compound interest is a lot more versus simple interest. So the compound interest formula, the amount A after T years due to a principal P invested at an annual interest rate R compounded N times per year is this formula. A equals P times 1 plus R over N, all to the N times T. Now, N is the number of times your account is compounded per year. So just to go over some very popular, or not popular, but things that you're going to see a lot, is you're going to see accounts that are compounded annually. So if it's compounded annually, that means once a year. If it's compounded semi-annually, that means twice a year. I always think of the Nordstrom half-yearly sale. It happens twice a year, or the Nordstrom semi-annual sale. All right, if you see it quarterly, that's 4 times a year. Monthly is obviously 12 times a year. So these are the most common compounding times you're going to see. So let's look at an example of this. Suppose you invest $20,000 into an account earning 5% compounded annually. So it's the same scenario that we saw with simple interest, but now instead of it being compounded or interest being done with simple interest formula, we're going to be compounding our interest. What will the value of the investment be after 6 years? So we're using this formula. So the amount equals the principal. So that's the amount that you start out with, times 1 plus the rate, 5%, and again we're going to write these as decimals, divided by n, which is the number of times it's compounded in a year. So if it's annually, that means it's compounded once a year, all to the n times t, so the number of years, which in this case is 6. When you substitute that into your calculator, you'll end up getting $26,801.91. I really recommend you do put this in your calculator yourself to make sure that you're putting things in the correct order and you have parentheses where they should be. You should get the same answer that I get. So what does this mean for how much interest this account's earned? Well, the account ended with a balance of $26,801.91. It started with an amount of $20,000, so that means the amount of interest that this earned was $6,801.91. So when you compare that to the last problem, that was just simple interest, where they only earned $6,000 in interest in that 6-year period. Now you can see they've earned an extra $801 on top of that. Let's use this formula to calculate the amount of money they would have after 1 year if you invest $1 at 100% compounded all of these different times. So I'm going to do the first 1 or 2, and then what I'd really appreciate you doing is pausing the video and working out the other boxes yourself, just to make sure you get a good practice with this formula and how it works. All right, so I'll write the formula up here. So for compound interest, it's A equals P times 1 plus R over N all to the NT. Now you will need to know this formula for the exam. All right, I really recommend you write this every time you use it, just so that it becomes like second nature. All right, A equals, so I'm going to write the formula, just because the more you write it, the more it gets in your head. All right, so the principal is $1. The rate is 100%. So if I wrote that as a decimal, you take that or decimal point and move it over 2 spots to the left. So that is 1 divided by the number of times it's compounded. So if it's compounded once a year, then that's 1. And this is all after a 1-year period. When you substitute that into your calculator, you will get $2. We look at it compounded quarterly. Again, I'm going to write that formula because every time I write it, the more it gets ingrained in my brain. Okay, so that equals 1 times 1 plus the interest rate, which is 1, divided by the number of times it's compounded. So quarterly means it's compounded 4 times, all to the 4 times 1. And that gives me $2.44. Monthly. So that means 12 times a year. I'm going to leave it to you to write this formula out every time because I already have it memorized. So A equals 1 times 1 plus the interest rate, which is 1, divided by the number of times it's compounded a year, which is 12 now, all to the 12 times 1. Substitute that in and you'll get about $2.61. So notice that as the number of times it's compounded is going up, the value amount in the account is also going up. So for daily, that means it's going to be compounded 365 times in a year. The amount equals 1 times 1 plus the rate divided by the number of times it's compounded in a year, all to that n times t, which gives us about $2.71. Hourly, so there's 365 days in a year, times 24 hours in a day gives us 8,760. So that's how many times it'll be compounded within that year. All right, so amount equals the principal times 1 plus the rate divided by the compounding time all to that compounding time times the number of years. And that gives you about 2.72 every second. So in a 1 year period, there are 525,600 seconds. So that means that it's going to be compounded that many times in a year. So the amount equals 1 times 1 plus 1 over 525,600, all to the 525,600 times 1. When you substitute that in your calculator, you'll get about 2.72. So notice that as the compounding period is getting larger, where it's happening not only every day, not only every hour, but every second, we're getting really close to this number 2.72, which, if you recall from the exponential section, is E. And this is where our next formula comes from.